Hello. Thank you for joining today's JTD on flexible disk space. I'm Mike Gerdts, and Pedro will be talking a little bit later. We will start out by talking about the problem we're trying to solve, how we're trying to solve it. We'll give a little bit of an offering to the demo gods. I'll talk about the SmartOS changes, and then Pedro will get into the Triton changes. First off, we'll start with the problem statement. So when we introduced bhyve, we had some people that wanted one large disk. These were typically Windows users that have a need for an application that wants to install to the C drive. It keeps all of its data in the C drive, and they have no use for a second drive. But depending upon what the application is, they might want a different size. We had some people that wanted to have several disks. So 1, 2, 3, 4, who knows? Not necessarily hundreds of disks, but more than 1 or 2. There isn't a clear agreement on what size any disk should be, and lack of agreement on size actually causes some problems for operators, because they aren't able to efficiently pack systems so that the RAM, CPU, disk are all used in a way that they can charge for in an efficient way. And along the way, people also want snapshots, and this is kind of wrapped up in how we manage disk space. So what we've decided on is specific to bhyve. We allow space to be reserved for future use. We allow a variable number of disks, and we allow snapshots. The things that we had to be sure that we took into account were, first of all, that predictable is often more important than most efficient. So by predictable, I mean that people want to be sure that when they have reserved some disk space, it really is reserved, that they aren't going to find out that, oh, somebody came and used the disk space that was promised to them. In contrast, many times you get into an oversubscription model, which may be more efficient for system use because you can use more of the space, and if you do it right, you usually don't run out. But there are still some times where you run into some surprises. Virtual disks are very different from file systems. So a virtual disk is a block device that's presented to the guest in the host OS and SmartOS. That is created just as a ZFS volume. So there's a lack of knowledge of how data from the host maps to what's in the guest from the host view. So that generally makes it so that grow is safe, shrink is not. If you try to shrink a volume or try to shrink a virtual disk and the guest has written to that, that turns into data loss in the guest. Free space management is complicated with snapshots. This is largely due to the fact that that the host doesn't know what space is really in use by the guest, so it assumes that if the guest has ever written to a block, that it's in use. If the guest goes and removes a large file or reformats the file system, and there's really very little on the file system that's in use, the host has no idea. So when you create a snapshot, you have to snapshot all the data that was ever written. This may improve in the distant future as the VirtIO spec gets support for discard or trim, which would make it so that say when ext4 does a removal of a file, it could tell the block device, free this space, free this 1 gigabyte of space, and that would turn into a call on the host side that we would be able to translate into a ZFS action to actually free those blocks. Again, that is distant future. So because of the way that the host doesn't really know how the guest is really using the space, snapshots could be abused to consume all space. So this would happen if, say that the guest were to fully overwrite a disk, they create a snapshot, they fully overwrite the disk again, do that many times, and each time it winds up taking up the full amount of space of the disk to store that snapshot. But we do have mitigations for that. And RAID-Z with small blocks, which is common with virtual disks, can be surprisingly inefficient. This creeps up mostly with more modern disks, especially SSDs. There is a separate JTD on that. Follow the link below to get the full details on that. So the SmartOS changes include persistent PCI slot. We have a new property, flexible disk size. We're able to add, remove, resize disk with VM ADM update. We're also able to use VM ADM for snapshots and rollback. And there's also a variety of ZFS fixes. I'll demo each of these. So first of all, PCI slot. So I have a couple instances here. Let's install VM ADM list. So I'll only be looking at this bhyve instance here. So if we do a VM ADM get, we see that this this machine's disks, we have disk 0 and we have disk 1. They have, this one is in PCI slot 041 or 040, and this one's in 041. If we look at this from the guest side, we also see that there's a VirtIO block device at 040 and at 041. So the PCI slot can be set whenever the disk is created. So that can be as part of the VM ADM create payload, or as you're adding a disk with an add disks payload, you can also set it then. It can't be changed with update right now. That's just more of a matter of it's not implemented rather than it's an issue of it really couldn't be done. Note, however, that if you were to move a disk, not all file systems are tolerant of being moved. Next up, we'll talk about the flexible disk size. So if we do a VM ADM get that VM, I don't have a flexible disk size set. Okay, so that's going to be the default. When you're provisioning a VM, you would typically set this if you're going to use the feature. You can set it later. So without it being set, if I do a ZFS list, let's get that for my history. Yeah, that looks right. Okay, so here, without flexible disk size set, this is what is initially implemented in bhyve. We have rough reservation set on the zones file system and each of its disks. So on the first disk, the rough reservation is 10.6 gig, which is the 10 gig image size, plus half a gig for metadata. And then the second disk I have set at 256 meg, and it has 266 meg reserve, so again, for metadata space. If you add 1 gig, 10.6 gig, and 266 meg, you get 11.9 gig, which is the total reservation for this particular VM or this zone. The ref reservation is currently set to the same amount as the quota, but only on the file system that contains all the disks. What this does, by setting the quota to the same as the ref reservation, is it makes it so that we can't create a snapshot of this, or more importantly, we can't create many snapshots of this to consume all the space in the pool. With but we should be able to fully overwrite each of these disks. Because of the aforementioned RAID Z complications, which we did not initially understand, if you are running a platform image prior to July 18th of 2019, so 2019078, this ref reservation may be the wrong size for a disk, particularly if you're using RAID Z. So you're encouraged to use a platform image that's later than that. So again, we're capped at 11.9 gig. If we were to update so if I do a VM ADM update of this, and I set flexible disk size equals, and then we need to give a value that's in megabytes, but so I'll do a little math here, 20 times 1024, and okay, so we did the update, and now we have about another 10 gig available. So now I have space that I'd be able to create a snapshot or many snapshots, or I'd be able to add disks, or I'd be able to grow disks. So let's try to add a disk. So in order to add a disk, the VM has to be stopped. Okay. So currently these are the disks I have. So I have disk 0 in PCI slot 040. It's 10,240 megabytes. With disk 1, it's 256 megabytes. If I want to add a disk, okay, so if I want to add a disk, I use an add disks payload and set the size to 512. Here I'm setting the PCI slot to a specific PCI slot. If you don't set it to a specific PCI slot, the next one will be chosen. So in this case, 042 would be chosen if I didn't explicitly set it to 047. There's really no reason for setting it to 047. I just wanted to demonstrate that it can be done. So if I do a VM ADM update, svm-f add disks.json, and then I do I list my disks again. I see that I have one in PCI slot 047. It's 512 megabytes. That matches up what you expect. And if I do a ZFS list again, I see that I now have another, I have disk 2, it's 512 meg for the vol size, and 530 megabytes was reserved. The quota and ref reservation did not change from what we had earlier in this column here, or this row here. So if I want to remove a disk, well, actually, let's take a look at what happened inside the guest as well. So VM-ADM start this guy. And so it's going to take a couple seconds. It's sitting in the grub prompt for 5 seconds or so, and then it continues to boot. So we'll do our SSH LSPCI back to grub block. Still on its way up. Okay, and now we can see that we have at 047, we have another disk. Nothing happened to that disk in the guest, so it's your responsibility to log in, or it's the VM owner's responsibility to log into that VM and do whatever they need to do for creating a file system on it or whatever they need to do with that disk. So if I want to grow a disk, I can do that with an update disks payload. So if I want to do a let's say I want to resize this disk. Actually, before we do that, I would like to actually remove this disk that we added earlier. So so I want to remove a disk. You have to create the remove disk payload with a list of the disks to remove. And you do that by the path that they are at. So again, if you do a vm-adm get, you can get that you know, of course, another way to do that would look like this here, which is the format you're probably more familiar with. In any case, you want to grab the path and put that in your remove disk payload. Then you can do a vm-adm update. But like all the other disk add, remove, resize operations, you only have to do that. You can only do that while the VM is stopped. Okay, if I do the ZFS list again, we'll see that that's gone. We'll also see that it is gone from the VM's configuration. Okay, let's go back to growing a disk. So this is probably more common than adding a disk, I'm guessing. So I'm going to demonstrate growing a disk here, but you can also specify the disk size during VM creation. Even for disk 0, you can specify the size. It just has to be at least the size of the image. If it's larger than the image, it will automatically grow that disk from the host side. And depending upon what software is running in the guest, it may or may not grow the file system in the guest. So if I want to resize disk 1, I do that with an update disks payload. Again, you specify which disk by the path, and then the size to be whatever size you want. That size is in megabytes. So vm-adm update. And now if I do a ZFS list, I see that this volume is now 1 gig. Ref reservation is increased accordingly. And in our configuration, it's also set appropriately. If we look at this from inside the guest, we can see what's going on there. So this particular disk is mounted on DevVDB. In this case, the guest did not automatically resize it. So if it was during our first boot, Cloud.init would have sized this disk to whatever the maximum size of DevVDB is. Since this doesn't have a partition table, you can just do whatever the growfs file command is that's appropriate for the file system that's there. But since this has not been grown, let's pretend that this was actually an accident and grew the wrong disk. We can actually shrink it as well. So vm stop. So resize can be used for resizing up and down. So if we said, oops, I resized the wrong disk, or I resized it on the wrong VM, or I resized it to the wrong size, you can actually shrink it as well. So vm update. But since shrinking a disk can eat the data, we make sure that it's really hard to get that wrong. So if in this case where we're only dealing with a small number of megabytes, it's not really hard. It's kind of hard to get the number wrong. But if this is a much larger value and you have one too few zeros when you're trying to grow a file system, and it makes it so that you would actually wind up shrinking it, that could be very, very bad. So when you're shrinking a file system, you have to, or I'm sorry, when shrinking a disk, you have to set dangerous allow shrink to true. When you're not shrinking a disk, that should not be present. So if we do vm update now, if we do CFS list, we'll see it's back down to its originally 256 megabytes. And we can do the you can see here in the configuration, it's also back at 256 megabytes. So the last thing to show is snapshots. So snapshots can be created during VM creation, or I'm sorry, VM. Let's start over on that. Snapshots can be created when the instance is running or when it's shut down. So if we start this guy up, we can do a vm get this guy JSON snapshots, and we have an empty list. So if we go to SSH into this guy, oops, Ubuntu. Okay, so nothing there. Touch before snap one. And now we can do vm create snapshot, that guy, and we'll call it snap one. And now we see that we have snap one. And if we SSH in again, we'll see we have before snap one, touch after snap one. Okay, so we have a couple files there. And let's create a second snapshot. So now we have our two snapshots. If we want to roll back to a particular snapshot, we have to do that when the VM is stopped. So vm stop that guy. Okay. And to roll back to a particular snapshot, we will do a vm rollback snapshot, VM UUID, and then the snapshot name. So we'll roll back to snap one. So in addition to rolling back the snapshot, this actually starts the VM as well. Since we rolled back to snap 1, that should delete any snapshot that was created after that as well, which is what we have there. If we log in and we take a look, we only have the before snap 1 file because we rolled back to the state before we created after snap 1. So there's really nothing magical about this. It works pretty much the same way that that snapshots work in with any of the container brands. And so with Joyent Minimal or LX zones. There were also a variety of ZFS fixes that have happened. These are mainly related to how ref reservation is calculated and adding the ability to do a ZFS set ref reservation equals auto. Those are really implementation details that are used by VM ADM. So I have talked a little bit about this already. So the ZFS properties that are in play here are ref reservation. So ref reservation applies to a specific file system or volume. It does not, so it says how much space is reserved, how much space is guaranteed to be available for that file system or volume. It does not say anything about the amount of space that's available for snapshots or the amount of space that's available for child data sets. Auto is a special value, so if you do a ZFS set ref reservation equals auto for a volume, it will calculate the amount of space that's needed for the block pointers and indirect pointers and things like that. There's also a similar property called reservation, and that is the amount of space that's available for the file system and all of its children. So as you recall, so it's the reservation is abbreviated as reserve here, and ref reservation is ref reserve here. So we wind up reserving the amount of space for this entire hierarchy, but each of these values in the reserve column only apply to the thing that is to the right of it. So vol size is the logical size of the ZFS volume. This is the amount of space that the guest will see. Ref quota, which I haven't talked about yet, is for a specific file system or volume. We don't really set it on volumes because vol size already does what we need it to do. But in the case of the file system here that the zone is in, we set ref quota to be 1 gig, which matches the ref reservation. Essentially, we're saying you're promised to be able to write a gig of data into this file system, but you can write no more than 1 gig of data into that file system. And this file system just has logs and metadata, maybe firewall rules, things that should be relatively small. So 1 gig is generally going to be way more space than what's needed. And then quota is for the file system and all of its children. So here we set quota on the top level file system, and that restricts the amount of space that can be used by this file system and all of its descendants. There is some discussion about whether we should be setting quota by default. Really, it's only important to set quota when we have a when snapshots can be created by somebody that's untrusted. So in the case of of SmartOS, it's probably not terribly important to set quota. It actually gets in the way of people that want to create snapshots outside of VMADM. Some people use zRepl for being able to replicate their storage to another machine for backups. And so quota gets in the way for them. There would need to be some tie-in to Triton for this, so that customers that are allowed to use snapshots aren't able to chew up, an unlimited amount of space in the pool. Details on that will come later, though. Okay, so the value of quota is used with flexible disk space, but in ways that are different than what you would see with a container. So in the packages API, PAPI, the value of quota is the same as flexible disk size when flexible disk is set to true. If flexible disk is not set to true on the package, then quota is the size of the second disk. With Cloud API, the package's quota is visible in the package.disk property. So you can do a Triton package get whatever the package is, pipe JSON disk to see that value. In VMADM, flexible disk size, like I said before, matches the quota, but only when the package is set to flexible. When package flexible disk is set to true. In VMADM, quota is this is an oddball here, and it's measured in gigabytes, where the others are measured in megabytes. The VMADM quota is not related to flexible disk size. This is that 1 gigabyte that's available for the logs and config and such. So that is the ref quota on the zone path dataset. So the ZFS quota on the zone path dataset is the flexible disk size plus metadata size plus the ref quota on the zone path dataset. And like I mentioned already, ref quota on the zone path dataset is the same as VMADM quota, but completely unrelated to flexible disk space. With that, I will pass the baton over to Pedro.
Okay. So we are at the same place we were before. So pretty much everything on Triton is exactly the same that Mike has already explained for VMADM and the underlying operating system. So as you know, for Triton to create a machine, we need the information from Image API, from PAPI, and use that from bmappy in order to create a machine. So we need to introduce some changes first to PAPI in order to create packages which are able to create this kind of machines. And the PAPI changes were pretty straightforward. We just added the flexible disk boolean, so that means that exactly what Mike showed before, that when we set flexible disk here, we will set that attribute in flexible disk size to the package. And we add a disks attribute to support multiple disks for a given virtual machine. This is a collection of objects, either with some particular values. So when we, it could be an empty JSON object, which is recommended for the first disk, for the image disk, because that means just as in this disk, the size the image says it's needed for the operating system, exactly that size. So you don't have to care about the right size for the operating system. Then you can also assign a custom size property, which will be in megabytes, as explained before. Or you can leave it set to the string remaining. So if you have, for example, a package with 3 disks, and you set the first one to the empty value, the second one set, for example, to 512 megabytes, and you left the third one set to remaining, the third disk will be ground to take all the space available for the machine. So up to quota, whatever is left up to quota. This is handy sometimes, but it's also dangerous because if you set the size of remaining into a disk, you will not be able to create snapshots of that machine. And right now, you will not be able to migrate that machine too. So, but I mean, sometimes you just want to use a huge disk, and that's a possible solution for that. Then we made a lot of changes to bhyve in order to support everything here. So the first change was to allow snapshots of bhyve VMs. Then we added flexible disk size support into the bhyve payload based to BMADM. And this has the meaning described here. When we have a bhyve VM and the package has flexible disk set to true, the VM will have a flexible disk size attribute, which is exactly the value of package quota. So this, I think, at least on, on this slide, we can clarify something. Flexible disk size is set exactly to package quota when flexible disk is set to true in bhyve. So, I mean, I know it's somewhat confusing, but I think at least this one is pretty straightforward. And then we also, if you take a look at machines, I will show a little demo later. BMADM also lets you know what is the free space for bhyve VM. So you have a quota, you have flexible disk size, you have several disks. So we thought that it would be a good idea to have a quick way to know how the space which is left for the user to use, either to add new disk or to create snapshots or to whatever else. Obviously, we added these endpoints, create this, resize this, and delete disk. We also allow the creation of VMs with disk specified by the package. We added support for the remaining value for this size, as we commented before, both for when we create a disk and also when we create a machine. And then, and not less important, we decided to stop passing quota value to BMADM for KVM and bhyve VMs. I mean, because this value has no more meaning than the already set quota constants for KVM and bhyve VMs into BMADM. And what we need to pass is the values for disks and flexible disk size, which is what is going to be used for real. So this is a small but important change in bhyve, so we don't try to override quota, or at least we don't let the user think that we are allowing it. Then moving up on the stack, we also added Cloud API, exactly the same endpoint, exactly the same support for both, for packages and VMs, support for disk, flexible, and disk size and free space. In order to make things a little bit more confusing, instead of flexible disk, here it's called, the property is just called flexible. This usually happens when you have several people working into the same thing at the same time. This here is has exactly the same meaning than for BMADM and for bhyve, but it's somewhat simplified. So we left the disk into just ID and size. And the operating system disk also have the attributes image, which is the string which holds the image UID, and boot, which is just a Boolean value, meaning that this is the boot disk. We added exactly the same endpoints: create machine, resize machine disk, and delete machine disk. We also added the get machine disk and list machine disk because we found that it would be probably more REST friendly than just adding these 3 endpoints. Added also support for the remaining disk size value for both create machine disk and create machine. We make sure that the disk attribute for Cloud API, when you see this attribute into a machine, it has the value of flexible disk space for bhyve VMs instead of Coda, because it's not related at all. And then we fixed some bugs thanks to the QA team, because, for example, we were allowing the creation of instances with the first disk being smaller than the image size, or run error messages, or another kind of stuff. So thanks to the QA for their help on this. And in Node Triton, the implementation is pretty straightforward. We added support for everything we already had into Cloud API. So I will try to make a little demo later. And finally, for AminoI, we have already started to implement some of this. We don't have the time, neither not even the MBO for this yet, but we have started to put some stuff in AminoI, notably the things which could help us prevent breakness of stuff already there. So, for example, if you edit a package which already has flexible disk through AminoI, you will not break it. Exactly the same for VMs. At least you can see that a machine has multiple disks, and exactly the same for packages. You can get the values. We added some more facilities to package representation on AminoI. We have a lot to add yet into the machine view. Let me show you that. Let me share where it is. Here it is. So this is an example machine in can you see that on Quebec Cloud? And yep. As you can see, this have 3 disks. It only has the 3 disks. I mean, there is not yet option to add new disk, delete, resize, whatever. I mean, the idea is that this is going to be exactly like a snapshot or networks or whatever. But we haven't had the time to implement this yet. And also for packages, if we can get this package, this one has a couple disks here. It says that it has flexible disks. It's a bhyve package. If we go to packages and we try to create a new one, if we get, for example, if the brand is bhyve, we will be able to add disk and turn on or off flexible disk here. So we still have a lot of changes to make here, but at least we are not, when we edit packages, we are not breaking this. For example, this one, we are not breaking the disk, because if we don't add these changes here, we have the risk that somebody editing or creating new versions of packages through AminoI could definitely destroy some of the attributes, because neither the disk or flexible disk or the new properties would make it from AminoI to PAPI. So right now, after this, I mean, let me. Can you see my? Hold on. Let me share something else. Okay, this is my. Here it is. So this is Quebec Cloud, and this is. Well, let me see where I do have that. This one.
Do you want to make the font a little bit bigger so that it comes across on YouTube well?
Yeah, sure.
Thanks.
Yeah, definitely. So this is it. So this is my account on Quebec Cloud. Thanks, Dan, for this. So as you can see, these are the instances I have there. You can see that many are related to this second one. These are related to Cloud Firewall logging testing, but I'm interested only on this one, on TSRFD 154. Hold on, I think I got this one is much better. The font is bigger. Okay, there you have. So let me hold in this help. Let me show you this. This is what we added to Node Triton. So be able to add this or list this or get or delete or resize this for a given bhyve instance. So for example, I already have an instance here, which is stopped. Oh, let me so there is something I want to show here, a couple things. Here it is. So here you can see the disk through Node Triton. Here you see that the disk has size, boot, image, and ID attributes. If you do check exactly the same machine through Quebec Cloud, let me make the phone like bigger. And you will see that it's quite close to what Mike already showed up on the other places. By default, bhyve displays all the attributes set for each one of the disks the machine has. I mean, everything: path, the model, the size of the image, PCI slot. And here in bhyve, we can specify PCI slot, and we can also specify PCI slot for Cloud API. Right now, we are not doing that. We are not yet implemented doing that through Node Triton. But let me ins this. So we have a PCI slot anyway displayed for each one of the. Well, I think. Oh, sorry, maybe I'm on a mistake. Ins help. So no, you can only specify instance ID and the size in megabytes or remaining. You can specify PCI slot through Cloud API, and you can specify PCI slot through bhyve. And then, as we commented before, we have some exciting values. For example, here we have a quota of 1, which is the default value set for bhyve snapshot, bhyve machines into BMADN. But this value is not meaningful at all for a bhyve machine. It's left here just to try to not break things like a BM agent. And the meaningful values are these flexible disk size and free space, which are, which mean respectively all these being in use for the whole theme, data set, snapshot, children, whatever. And this the free space, which is the space still available, which could be also used for snapshot and that kind of stuff. And a part of this, well, we can do exactly the same thing that we do for BMADN straight from on the top of Node Triton. So adding a disk to the instance. Here the raw messages try to be a little bit more helpful than BMADN, but anyway, we are still on kind of testing this. This is just so you get the disk here, and then you try to, if you get this one, you will get by default in JSON format, and you can resize. Yeah. So the W is just the white flag, so we wait until the job is completed, so Node Triton keeps polling until we get the operation done. And so you have it's already resized, and you can try to resize down. and you will see that you need to specify dangerous are always ring here too, because the user will complain. So let's do that. And you can also, once we got the disk here, you can also delete the disk as we would do with anything else. So it's pretty, in Triton terms, it's pretty much very simple in Cloud API terms, a very simple REST API on top of everything, which is just add, get, create, get, list, update, and delete. Update meaning resize here, and that's it. I mean, exactly the same restrictions that underlying the machine needs to be running, and that needs to be stopped. I mean, you cannot resize this on a machine being running, and that pretty much is it. I mean, just to mention that if you don't have any free space, I mean, if you get hold on, if you don't have any remaining free space for an instance, you cannot create a snapshot. So if you see here, we have flexible and we have free space of 29 gigs, a little bit more. So right now you can create snapshots. I will not try to create a disk with space remaining because the operation will probably time out. I'm not sure. I mean, I would try, because this one, yes. No, hold on. I need to exact the remaining. Yeah. Not sure if this will not be timeout. I think right now is that timeout is of 2 minutes or something like that. So the workflow, maybe less. So the workflow will, the job polling may time out before we create the disk. Or at least it used to do into my code, but that's a different, completely different story. So other than this, I think that I know that this may be somewhat confusing, even more considering that we don't have the latest Cloud API docs into neither Molybdenum or the JPC public docs. So there is actually no information for create this and delete this and resize this, but that information is already written. So if while this finishes, let me try to solve something else. I think I have this here, maybe. I'm not sure. Let me check. Hold on a sec. Why this isn't opening there? Let me try to get the right file for this. Oh, what? See, it opened me into a different screen. Okay. Let me try. Here it is. So this should be it. On instances, we get this information, which is as I think Brian who asked it before. So we have here PCI slot, which can be implemented through Cloud API. It's optional. If you implement a PCI slot, which is already in use, you will get an error. And otherwise, you will get the default PCI slot. I think it's the next one, if I'm not mistaken. Mike can correct me. And then these are the fields which can be used which will be used for a disk. Not only state is a string, which is, so it should always be running, but in the case it's creating, which is indicating that the job has not finished yet. But other than that, you probably shouldn't care about it at all. There is also resize machine disk endpoint, get machine disk, list machine disk, and delete machine disk. You can get all of these just by running make docs into the Cloud API repo. So I suppose that we will be able to figure out a place to put these docs so you can take a look at them. And also I have made a little gist here with almost everything I have said and some examples for packages. So for example, this one has just 2 disks. This one has 3 disks. As I commented before, this one is empty, a given size, a size of remaining, and some other examples which you can use to just a little bit of reference, because I know that, and also how to use Triton to create all these packages. I think that we have everything you need to play on Quebec Cloud, so you can test there if you want to create a user. Or otherwise, we could also talk to QA, so we can create somewhere, we can play somewhere else. Also, if you install the latest code, everything you need to run code should be available for you. And finally, there is a note I think I've missed from the presentation that I want to come back to, which is that, yeah, here it is. Is that creating snapshots of bhyve machines through Cloud API is not enabled yet. In order to enable it, you need to explicitly set this value to true. Experimental Cloud API bhyve snapshot. So I mean, you said this. It's explained here, and that pretty much is it. That's everything. You need to. Otherwise, you will get an error when trying to create the snapshots. I think I got that also covered here. I will share the link with you later too. So when you try to create it, you will have this exception. The snapshot of bhyve VMs are not allowed. So when you try to create a snapshot of one, so let me copy this before I forget. And that's everything from my side too. Now, if anybody has questions or comments or concerns or whatever, this is the gist with this stuff, which I just passed it on Viv.
Does anybody have any questions, comments? All right. I guess that will conclude today's session. I also have a gist with the with everything that was supposed to happen in my demo, so I will make that available as well. Thank you everybody for joining.